The sun is more than a bright disk in the sky, it's the engine that runs Earth. It contains about 99.8% of the mass in the entire solar system, so everything else, planets, moons, asteroids, is basically orbiting leftovers around one massive star. Deep in its core, the sun is a physics experiment on an unimaginable scale. Temperatures reach roughly 15 million degrees Celsius, and the pressure is so intense that hydrogen nuclei can fuse into helium. That fusion releases energy because a tiny bit of mass is converted into power. Literally E equals mc squared happening non-stop. Every second, the sun outputs more energy than humanity has used in all of history. What's crazy is how far that energy travels. The sunlight you feel on your skin left the sun about 8 minutes ago. But before it escaped, that energy may have spent an incredibly long time inside the sun, bouncing around as particles of light get absorbed and re-emitted again and again. In other words, the warmth on your face today might be the final step of an energy journey that began a very long time ago inside the solar interior. The sun also isn't a solid object with a surface you could stand on. It's a ball of plasma electrically charged gas. What we call the surface is the photosphere, the thin layer where light finally escapes into space. Above that, the atmosphere gets even stranger. The corona can reach millions of degrees, far hotter than the photosphere, and scientists still study exactly how that heating happens. Then there's the sun's magnetic personality. The sun doesn't rotate like a rigid sphere. The equator spins faster than the poles, a behavior called differential rotation. That uneven spin twists magnetic field lines until they tangle, snap, and reconnect. The visible clue is sunspots, darker patches that are cooler than the surrounding area, still extremely hot, just less hot. When magnetic fields release energy suddenly, the sun can launch solar flares and coronal mass ejections, blasting charged particles into space. When those particles interact with Earth's magnetic field, they can trigger auroras and sometimes disrupt satellites, radio signals, or even power systems. So the next time you see sunlight spill across a wall or feel warmth through a car window, remember, you're witnessing a steady, ancient fusion engine, sculpted by magnetism, powering life from 93 million miles away.